Hello friends, welcome back. Hearty welcome to you. Let us look at this problem. This is for 8th grade or 9th grade syllabus. Prove that in a right angle triangle, hypotenuse is double the shortest side given one of its acute angle is double the other. That means we have a right angle triangle in which angle B is 90 degrees. We have been given that one acute angle is double the other. So other two angles, let us say, are x and 2x. Now can we find out these angles? Let us see what we can do with that. So we'll write down x plus 2x plus 90 degrees is equal to 180 degrees. That means 3x equal to 90 degrees. Now we can solve this problem with 10th class knowledge by trigonometry, but 8th or 9th grade level we want to solve it only by geometry. So x equal to 30 degrees. Now we know that the angles of these triangles are 30, 60 and 90 degrees. Now how to prove that AC equal to 2 times of BC? Now you can see that we have here 30 degrees, we have 60 degrees, we have 90 degrees. Now suppose I extend BC to the BD, let us say, by the same length BC, what I will have? I have same triangle, congruent triangle flipped. So that means we will have here also 60 degrees and there will be 30 degrees. That means this total triangle will become now an equilateral triangle. Then we can easily find out what we need. So let's go ahead and do that. So what we will do as part of construction, actually what we want to do is take this ABC. We want to take this ABC triangle and just flip it. When you flip it, what we'll have? We will have another triangle which is congruent to each other. So for that we will do a small construction. We will write down what is the construction we will do. We will extend BC, produce or extend BC to, or can I say CB to CD. I'll write down produce CB to CD such that BC equal to BD, such that BC equal to BD. What is the meaning of that? Now take BC, whatever we have, and extend this on the other side so that this side is equal to this side. Now these both are equal. Now let's go ahead and join this. Now what will happen? Now you can very clearly see that these two triangles ABC and ABD triangles are congruent to each other. Let's prove that first. Then automatically we can put the angles. Actually we can say that we just flipped it, but we want to prove it. So we'll go ahead and write down. We will write down in triangle ABC, comma triangle ABD. What is the construction we have done? We have extended CB to CD such that CB equal to BD. So we have one more 90 degrees angle here because it's a straight line. So we have one more 90 degrees. So let's go ahead and write down in these two triangles what we know. We know that AB is equal to AB, which is common side for both the triangles because we just flipped the triangle. That's what we did. So it should be obviously congruent. And we also know that angle ABC is equal to angle ABD, which is equal to 90 degrees. We also know that BC is equal to BD. So you can see that triangle ABC is congruent to triangle ABD by which congruency we have? SAS congruency. By SAS congruency. By CPCT, what we are going to get by CPCT? By CPCT, we get AC equal to AD. We get AC equal to AD. Not only that, we get angle BAC equal to angle BAD. Can we write down that? Angle BAC equal to angle BAD. Not only that, we get angle ACB equal to angle ADB. I'll write down that also. Angle ACB equal to angle ADB. Now what is the meaning of that? Let's try to put it in the diagram. What we understood from that is that this angle is also x and this angle is equal to 2x, and we have these two sides are equal. Now let us look at now triangle ADC. What we can say about that triangle? We clearly know that x is 30 means 2x is 60 degrees. So we have 160 degrees here. We have 160 degrees here, we have 160 degrees here. So we made it as an equilateral triangle. To actually just make it pretty simple, what we did is, we took the right angle triangle, we just flipped it, because we know the angles are 30 and 60. If I flip it and add it to the current triangle, I will get an equilateral triangle of 60 degrees. All the 360 degrees, one equilateral triangle we will get. So now let's look at triangle ADC and try to solve this. We'll write down. In triangle ADC, we know it's an equilateral triangle. That means we have AD equal to AC equal to DC. That means AC is equal to DC, but DC is equal to 2 times of BC, because we know B is midpoint of CD. So that is what we need to prove. AC equal to 2 times of BC. So let's have a recap of this, what we have been asked to solve. We have been given a right angle triangle, and in which acute angle, one acute angle is double the other. We have to prove that hypotenuse is double the shortest side. What we have done, we observed the angles are 30 and 60 degrees. So we flipped this triangle, made one more congruent triangle next to that, so that we will make it as an equilateral triangle. And we know in equilateral triangle all the sides are equal. That means AC equal to CD, but CD equal to 2 times of BC. That means hypotenuse is equal to double the shortest side. This is how we have to solve it as with respect to geometry. Once we go to 10th class, we can use trigonometry and we can solve it easily, a little bit easily when compared to this. So that's how we solved that problem. Thanks for your time. Bye for now.